Good morning, good afternoon, and good evening as the place you are in. Welcome to AFOMP School webinars, which we started in last June 2021. And this is a special AFOMP School webinar in collaboration with the American Association of Physicists in Medicine, AAPM, and it is from the Global Research and Scientific Innovation Committee, GRSIC, which is being headed by Professor Robert Jairaj. And this special AFOM school is on Global School on Research Excellence. Thanks to Professor Robert Jairaj and Professor Magdalena Carter for having spare time. It is midnight there in US and Canada, the place where they are online with us. And this webinar will be moderated by me, and it will be the first talk will be how to write and review papers by Professor Robert Jairaj, whom I will introduce within a minute. Then we'll have questions and answers. During the talk, whatever question queries you get in, please type into the chat box. I will collect all those questions and put to Professor Robert Jairaj, and we will have a discussion. After that, Magdalena Carter will speak on how to write and review the grants, very important topic. And the questions, whatever you get it, please put it into the chat box. I will collect, and then we can have at the end of the talks general discussions one-to-one to so that we learn and we understand how to write, use papers as well as the grant applications. Professor Robert Jairaj is a very, very well-known, lot of publication, a lot of books and activities in the field of medical physics, radiobiology, and application. Still then, as a customary, I will introduce him. He is a professor at the University of Wisconsin, USA, and University of Ljubljana, Slovenia. Research focus on treatment response, treatment resistance, and clinical decision making. Published over 160 plus papers, mentored over 40 PhD students, and today morning itself, two of the students have got PhD awards. 50 plus MSc students, 10 plus postdoc, 50 plus visiting scientists, lot of research activities. Professional activities, he is the American Association of Physicists in Medicine, member Science Council and International Council, chair Future of the Medical Physics Research and Academic Training, chair Global Research and Scientific Innovation Committee, American Physical Society APS, founding chair of the topical group on medical physics. He is on the advisory board activities of the Commission on Accreditation of Medical Physics Program, CAMPEP from USA, National Physics Laboratory Metrology for Medical Physics Center, NPL UK, National Research Center for Radiotherapy, DCCC Radiotherapy, Denmark, editorial board activities, biomedical physics and engineering expert, physics and medicine in biology, European Journal of Clinical Medicine, molecular imaging, radiology and oncology. And we have established a good collaboration in the AFOM and AFOM countries with Robert Jairaj. With this short introduction, before I hand over the floor, I request all the participants to please mute their microphone and put off the video camera so that we get a bandwidth and there is no disturbance. Any queries you will have, please type into the chat box. I will see to those questions and then put to the expert Robert Jairaj. Now the floor is yours, Professor Robert Jairaj, for your talk. Just let me unshare it. Just a moment. Robert Jairaj.
Yep, I'm here. Let me just share my slides. I can see them. Can you see the slides?
Yeah.
Yes, you can. Wonderful. So first, thank you very much for the kind introduction. And I would also like to thank you, Professor Chagul, for the invitation to partner with AAPM, specifically the Global Research and Scientific Innovation Committee. I think this is the first of its kind, and part of the reason is because the committee has been a little bit new to that. And I'll just, before I start with what we are here, I'd like to talk just a few slides to explain you for those who might not be familiar with the AAPM as much. So AAPM is organized in 5 councils, and one at the bottom that you see, International Council, is the one that has been created essentially last year. And all the international activities within AAPM are now, with this new structure, going and channeled through the International Council. So Council itself has 6 committees, and one of those that's committee that's in charge of the research and scientific innovation. So any international interactions between AAPM in the field of research or scientific innovation, they're within our committee. So the goals of this committee are really to coordinate scientific collaboration, develop global research resources, provide mentoring opportunities, and enable exchanges of scientific data, tools, and researchers. With 7 priorities, which include scientific education, international research resources, collaborations, research projects, clinical trials, scientific exchange, and then connection with multiple international organizations. So as you see that today's events essentially falls into the first priority, which means partnering in global aspects. And one of those things that we are doing, as you will see coming up, are some global webinars. We are starting an initiative with so-called Global Rising Stars. But there are also a number of other initiatives, for example, Global Research Mentorship Program that we're starting this year, and many others. So if I'll use this opportunity to also kind of like ask everyone who's interested in closer collaboration, wants to know more about it, or is interested in learning more and see how we can partner, I would kindly invite you to reach out to me. So, Global School on Research Excellence, as we already heard, will have 2 parts. So the main goal of this Global School of Research Excellence is really to try to kind of like globally got together to increase best practices that help researchers do good science, present good science, and also obtain funding to be able to good science. Obviously, there are local specifics, and every country would have some specifics, but some of the basic fundamental principles are actually the same. You know, everybody publishes the same papers, everybody reviews the same papers. While grants are different, you know, the same good practices and rules are the same everywhere. So that's what we like to do. And that's also what we like to hear from you, what you would like to hear. Because again, a big mission of what we would like to do is really to really partner and see how we can work together for the better world. So the first request that I really have is that I would like this to make it as interactive as possible. I would really like to hear your questions and address your concerns, and then just me talking about what I think you would like to hear. I think the Zoom is actually getting a wonderful opportunity to ask questions in the chat. So don't be shy. So ask questions as many as you can, as many as you want. If we don't get through all, we'll make an effort to do. There are 3 main parts of my lecture. One is how to write a paper. Then we'll talk briefly about the review process. And then the last one, how to review a paper. Again, we won't be able to cover many details, but that's why if you're interested, I'm always there available. So please send me an email, and you see there. So ruri@wisc.edu. That's my email address, or you could probably find it somewhere else. Okay, so just a little bit of my background, not to spend much, but my first paper that I wrote was in 1997, and it was in Monte Carlo simulation, believe it or not, of a research reactor benchmark experiment. The first paper I reviewed was in 1998, and then, as you already heard, wrote quite a few papers, but also review, I don't even know how many, but it's definitely more than 500 papers. So it's been a kind of like really fun seeing the development, and particularly has been kind of very enlightening my long partnership with the Institute of Physics Publishing, and particularly through being a founding editor-in-chief of BPAX. And that's kind of like seeing how the journal starts from the idea about the journal and then how it goes and grows through the years. Then spent many years on editorial board of Physics and Medicine Biology, as you know, one of the main journals in our field, but also been on a couple of editorial boards, currently on two others, European Journal of Nuclear Medicine, Molecular Imaging, and Radiology and Oncology. I should thank to two colleagues, Simon Cherry and Steve Michael from that were both my colleagues at the PMB board. There were some materials that I kind of like shamelessly took from their lectures, but also just part of that we did. So this is a kind of like group effort that we're working. So let's start with the first topics: how to write a paper. So the first thing when you write a paper, and I'm sure probably all of you have written some papers. If not, I'm sure you will. So I don't know what's the structure in terms of seniority of you, but I'm sure you've been there. So a lot of things that are probably talked won't be really new. So I'll probably more emphasize things that are maybe important, but especially for more junior researchers, I think there could be a lot of probably insights that can help writing better papers. So the first things that I think everybody should ask is ask some of the following questions. Did I address an important problem? Has anyone else addressed this problem? Is my solution novel? Are my results valid? Are my results conclusive? Will my results have impact on the field? And will my results have impact out of the field? So these are the questions that one would want to ask very honestly when you have something that you think to submit for publishing. Well, this essentially falls into four categories. They're usually or always judged in the review process as well. These are significance, novelty, validity, and impact. So all of the journals, when they look at, and reviewers look at these categories. So it's important to, even before you start writing, is address this and then explicitly state that in the paper as well. So planning for a paper is very important. And it's not just like you sit down and start writing. Usually it doesn't work that way. So usually it's good to start from the basics. So it's good to block out time to think about what to include in the article, what are the tables, what the data that you have, develop an outline. It's really important that you have a clear direction where you want to go. But also very important is to know, even when you write an article, to which journal you want to submit. Because there are specific journal instructions, requirements. There may be some specifics of the journal, but also the style. The journal style is very different from one to another journal. And if you don't write in the style of a journal, then you have a high chance of reviewers not seeing it as appropriate for the journal as well. And that would be, for example, having more clinically oriented papers submitting to more technical journals. That doesn't really go well. A good question is where to start. So one would intuitively think to start writing an article at the beginning. So, you think of a title, start with the abstract, and you go through introduction, methods, results, discussion, conclusions. Actually, it goes the other way around. So if you want to make a good paper, you want to know what's your main message. So what's your take-home message? And that's essentially conclusions. So essentially what you would want to do is actually start writing with a conclusion. So when you write a conclusion, you say, what's my main takeaway message? There is a good rule of thumb that you should have only one key message, not many, not 5 things, because if you take 5 things, people will forget all of them. So there's one important message that you have. If you have more, then probably it's worth more than a single paper. So that's a very important rule to have. You can have more derivatives. There are sub messages of those, but try to stick to one single key message. The second step is then to go to results and to say, which results do I have that support my conclusions? And the good rule of thumb is that you should show only those results that support your conclusions. There is no point of having like a lot of results that are irrelevant to what your message is. It's actually destruction to your message. So you start with the key message and then the results that support the message that you want to say. And then, of course, the very easy part essentially of the paper is just describe the methods and experiments. And again, however, the important thing is that you only want to describe those experiments that are relevant to each result. So you don't talk about the experiments that you've done because just you've done them. No, only those that are actually leading to the results which are leading to your conclusions. And then of course, you have to write introduction. And the introduction, it's important to address what's the gap in the current knowledge, what's a specific problem. But what's really important in the introduction that to be concise. It's no need to provide a full literature review. This is not reviews papers. Of course, we are talking about scientific papers. So that's why it's important that it's really concise. It's focused on the topic and some topic of what did you want to describe. So don't go too broad. And then, of course, you would want to continue with the discussion. Then when you have like the whole structure, you discuss when you put it, where you got it. So the good rule of thumb is that you clearly explain and articulate what your paper is about, but also what is not. So it's nothing wrong in a discussion when you say we've done this, but we haven't done that, or our results imply this, but they haven't gone that. So try never to go beyond what the results are showing, but it's fine to put the limits, or actually it's important that you put limits into where you've been. And of course, at the end, you would want to finish with the abstract, which is really an easy one, because essentially you want to summarize everything that you described in other sections. It is also the most critical part of your paper. And the reason is because most of the people never read anything beyond the abstract. So you think that everybody's going to read every word that you wrote in the paper, forget it. Most of the people will just read the abstract and maybe then go to some results, really interested, conclusions, discussions, a rally methodology, except if they're really in the field. But you know, if you look at the distribution, most of the people would be focused on the abstract. A good rule of thumb for the abstract is that you want to minimize the number of words and only say what absolutely needs to be said. So be concise, be very direct, don't overstate, describe what's in the paper. But again, if you just follow what is written, it's actually very easy to write the abstract. So do we have any questions at this point? I'm happy to, if there are any questions that anyone would have, I'm happy to, I'll stop from time to time and I'll review the questions, and then I can address any questions anyone would have at that point, rather than like waiting until the very end. Okay, I don't see any questions at this point, so I'll move on. But again, feel free to write. A very important question, often not properly or not known, is who should be the authors. And there is very important that only individuals that have contributed scientifically to the project should be listed as authors. So you shouldn't have authors that are just there because, you know, because they think they should be. It's for technical staff, it's only okay to be listed if they contribute scientifically. So if somebody did the work that's not sufficient for the paper, it needs to have scientific contribution. Some of the journals now require an explicit description of what each author's contribution to the manuscript was. And it's important to be honest about that. So there is International Committee on Medical Journal Editors recommendations, and here is the link that you can look and go to, and which very clearly specifies the criteria for the authorship. So the authorship should have only those who made substantial contributions to the conception or design of the work, or the acquisition, analysis, or interpretation of data for the work. Drafting of the work or revising it critically for important intellectual content by all the authors, and then all the authors should have the final approval of the version to be published. So, so this is an important one. So, I know there is a practice in some of the groups that just is considered that, whatever, some people in the lab or some higher ups would be automatically authors on the paper. That's not correct, and it's not fair, and it's not allowed. So only those who had substantial contributions to the conception or design of the work, not just because they're somewhere higher up. Agreement to be accountable for all aspects of the work and ensuring questions related to the accuracy or integrity of any part of the work are properly investigated and resolved. And this is something that's important, that it's signed. So most of the journals will ask you to sign agreement of accountability. And this comes that obviously if there is something wrong, you become accountable. And of course, occasionally it happens that there are certain things are not right. And then the accountability start being researched. So let's move on. Another common question is, or often not properly used, is like what stance one should use. So there are pretty well established rules, and that's when you describe an established knowledge, use a present tense. So for example, PET imaging of small animals enables longitudinal studies of the disease process. That's established knowledge, and that's where you use the present tense. When you describe unpublished work, like your methods, or previous studies, you use the past tense. So that means the phantom was placed in the field of view, or a dual-ended readout scheme for a DOI estimation was reported by blah, blah, blah. That's in the past tense. So you don't describe what you've done in present tense, or you don't describe what's been published previously in past tense. Only things that are common now, knowledge, one would say. Okay, common traps. Common traps are, which already a little bit mentioned, is that many of the articles are too long. Often introductions are too long. There are often too many results, including the articles, and writing style might be too verbose. That means too many words. So try to be clear, try to have short sentences, try to have pointed sentences. It's also commonly that the problem is not clearly defined. So when you read through the papers, like, what the heck did this others wanted to really do? Or it's like implied. So it's be very, very clear. Very often and commonly, conclusions are too broad. So the authors would speculate beyond what the results really are warrant the conclusions. So you can only conclude as much as the results are warranting. And then also common trap is that the sections are often mixed. So people would already in the introduction explain what the results are, or in the methods. So results go into results, not introduction and not in the methods. Or when you put the discussion in the results. When you discuss results, that goes in the discussion. Results are objective report of what you found, not a discussion of what you found. An important part to emphasize is plagiarism. I think this is also commonly a problem. And nowadays, pretty much every article in any respected journal is checked automatically for plagiarism. So, and that basically, that essentially shows there is so much overlap with the previously published work. And it usually would be expressed in percentages. So 60% of this paper is overlapped. And of course, there are some overlap, might be just certain phrases, since the senses that would be. But what's really critical, if there is found any overlap with any of the results, that's in particular. So if there is some overlap introduction, that's not a big deal. But if there is any note of any duplication of the results, be sure that that won't go well, because most often that would be automatically rejected even without any review. So in principle, you should not repeat any sentence or paragraph verbatim from previous publications, even if it's from your own work, or even if it's review papers. Reviews are a little bit giving a little bit more leeway. So ideas can be paraphrased but not copied. If you quote something, you should quote it. That's not plagiarism, but it's not necessarily good practice. But if you just have a critical quote, that's of course important to put, but then that should be put in a quote. So when do you know whether your article is ready? It's ready when there is no flaws or omissions, and you should be careful about this. If there are certain flaws, this is not a task for reviewers to find them. And this is something that really annoys reviewers. And once you annoy a reviewer, that doesn't go well, because then when the reviewer gets agitated, and even things that are not as bad will be seen not favorably. So try not to go there. So try to have well paper. So try to go below the threshold of agitating a reviewer. If only possible, papers should be proofread by at least one native English speaker, except if you're putting in a journal that's in a different language. And it should be in a required format. So often you would see articles submitted to journal that are clearly written for a different journal. And that's an easy giveaway that you're just shopping around and you were rejected in another journal. And reviewers are also very used to a certain format in a chosen journal. So the journals have their own reviewer base, and the journals are typically very familiar with what's the style of the journal. So when you submit a journal, you should confine to the style of the particular journal. And I mentioned before that all the co-authors should have read the manuscript and approved submission. Okay, I'll stop at this point and I'll see if there is any questions. Any questions on how to write a paper?
Okay, Gerard, I have gone through the chat box. As far there are no questions, but I have some questions. When you decide to write an article, now there are n number of journals. Some are online, some are paid journals, some are standard journal. What should be the criteria of choosing a journal? Okay, I will submit, or this paper should be submitted to this journal. So what are the criteria for choosing a journal?
That's a very, very good and not an easy question to answer, particularly because there are like many journals to choose from, as you said. So the first thing to think about it is the audience to which this your work is most appropriate. So for example, if it's more technical, you would want to go to a more technical journal. If it's more clinical, you want to go to more clinical journals. So it's important to know what the journal's scope is. So every journal has a scope, and it's important to know the scope and confine to the scope of the journal. The second important question is, what's the quality of the work? And the quality, the higher the quality, the higher impact journals typically you would go. However, it's not quite as easy. And I'll give you something which is relatively bothersome, and that is that often medical physicists, this is specific to medical physics discipline, would try to sell medical physics work in clinical journals. One, because they have higher impact factor, And second, because like that's relevant for clinicians. It's all true. But we know nowadays that everybody can find a journal or a paper in almost any journal. And it's known that from a study a few years back, it turned out that among the top 10 most impactful articles in the Green Journal, which is considered a clinical journal in radiation oncology, were medical physics journals, medical physics articles. And what that means is that essentially we are diminishing the value of medical physics in medical physics targeted journals because we are, often submitting to more clinical journals. Now, I'm not saying not to do this, but I think it's important to also nurture the quality of the journals in the specific discipline. So again, that's part of the complexity that one should consider. Now, when you look at the open access or non-open access, there is a significant trend towards open access required, but you should be very careful that there is quite a few or many so-called predator journals, which are basically praying for people to submit, pay, and they'll publish anything. Those predator journals stay away from, because if you go and you pay for something to be published, but it's not good, that will fire back. And of course, that's only supporting bad practices. It is true that open access articles in hybrid journals are typically receiving more downloads and more citations. And there's estimates about 100% more are from the open access journals. But personally, I still have aversion to the open access, even though there is a strong push, especially in Europe. Like Coalition S is one which is pushing for making all the journals open, which is creating quite a bit of challenge for the publishers as well. So I guess hopefully that answered your question, a little bit more complex space than just simply say choose A, B, or C.
Because for early beginners and the people who are eager and want to publish early, the journals they choose is the paid journals, though they may not have much more impact factor, but publishing many a times is an important thing, maybe for a career, maybe for a promotion or something like that, and they go for that. And once you establish yourself, a lot of publications and things, then you can be choosy to go for only the best impact factor or having a wide acceptance. So that becomes, to my mind, this choice depends upon you are early, eager to get published as soon as possible, or you want to send it to a very standard journal. So that is what I think. Second thing,
can we stop just a little bit? I would like to a little bit rebut what you said. I think it's partially true, but I think also I would strongly advise against sending. There is a lot of still journals which don't require they don't require publication charge, and they're very receptive for early careers because they are not necessarily, or they're encouraging, or the barrier of innovation or significance is lower than in some more established journals. So I would say that just in that sense, so I would strongly advise anyone to go somewhere, pay for something to be published, because it won't look good in the future when even you see that you have published in journals that are predator journals. So, but in general, that's usually potentially the process that you said. So sorry, but just wanted to add.
Again, you said that the manuscript should be read by the native English speaking or writing person, but there are nowadays professional people or professional systems which have come up and they say that we will write paper for you, or we will drop the things once you give the data. What is comment about these kind of services?
Nobody comes to me to do that, because I would just give them and say, like, please write. No, that was a little bit of a joke, but it seems like maybe it's more common in some other parts. And you know, it is a little bit, they're like professional writers. I think how to say, the substance and contents cannot be substituted by the non-expert writer. You know, the language and style can be refined. You can write a bad draft and somebody can polish it, you know, that. But I don't think there is just a way that anyone can write sensibly, because, you know, you cannot write a good article just based on the results. You have to know what's out in the field, what's important, which things you need to present, how you present. The discussion is totally, you know, it's only can be put in the context of the what's out in the field, you know, how it interpretation. So there's very few sections that professional writers can write, you know, well, without the background knowledge. So I think that the way to do is to write a draft. Might not be as good or as polished, and then potentially get somebody to clean the language. But definitely don't give anyone the substance. You're not doing yourself a favor, and yeah, I doubt that the results in the long run would be especially not for any journals with a significant impact, or like, you know, reputable journals that won't go too far. You might be lucky one time, but it won't work in the long strategy.
And regarding the plagiarism, how much percent of the plagiarism is accepted? One thing. And another thing, there are some standard phrases or nomenclatures or the things which sometimes the software detects it as a plagiarism, and then the same report is sent to the author to look into these things, and that raises some of the problem, because some standard phrases, some standard nomenclatures are there. Some software, they take it as if it is just a plagiarism.
So there is not a magic number for one. And the reason is because, as I mentioned earlier, it depends where the overlap is. I've seen even up, you know, like in the 20 percentiles of the overlap to still be acceptable if it's mostly in the introductory or possibly some in methodology. But I said, like, forget any overlap in the results, you know, like I would say like phrases, you know, it's something which is overlap in the phrases, and something is like literal sentences or a section of the sentences. So when you have like, you know, part of the sentence, or a sentence here, sentence there, but it's not like, but when you have like blocks, that doesn't go well. And it doesn't matter what percentages. So it's the pattern of the overlap that comes from the analytics, which defines the plagiarism. It's
if I can I
yeah,
as well interject?
Absolutely.
So I'm a deputy editor of medical physics, so I see these reports on a daily basis as well. And so I would say, you know, in the tens of percent, it's not really an issue unless this is from a single source as well. That's, you know, if it's from a single source and the source is not even cited, then you're going to be flagged for plagiarism. So you have to make sure that you cite the work that you are you know, using, I guess, plagiarizing, I don't know. But as Robert's saying, it depends where it is, right? If it's in the materials and methods, sometimes that's okay, because it could be, you know, the same methodology that you used for a previous paper, it's copied from your previous paper. It's not a big deal. If I see, you know, a lot of overlap in the results section, in the discussion as well, that definitely raises eyebrows, and I have to go, you know, basically to the paper and see what the overlap is. Don't reuse figures either. That doesn't bode well either. And if I see, a complete figure caption that's overlapping with a previous work, again, that's especially if it's not from your work and not cited, that's a problem then. But we might want to avoid, overlap with a single source. Too much overlap.
So let me just give you an anecdote. Everything that Magdalena said is 100% correct. It matters what is duplicated, but in principle, the sources should be listed. But sometimes, and there was an anecdote that I said, was we got a paper that actually plagiarized its own paper, and actually it was microscopic slide that in the other paper was taken a different part of the microscopic. So that's like the slide in a microscope. They took one part and then the other part, but there was enough of the overlap that, of course, like the software did not detect, but the reviewer did detect. And actually, they also turned that slide away. So people get very how to say, sophisticated in plagiarizing their own work. Creative plagiarism. But I'll tell you that the action item on that kind of plagiarism is not well. So typically plagiarism would be reported to your superiors and typically to all the way to the leadership of the university or institution that you are. You would be banned, you would be flagged. So don't even try to go there. So if it comes that's serious and detected, there was something intentional. It's sometimes hard to prove, but when it's proven, then there is absolutely no mercy. Your career is close to done. There are like plagiarism that we've got reports from colleagues that somebody else was plagiarizing, etc. So there is like a lot of stories. We could just spend the whole time just talking about that. Again, the message here is don't go there, because it's bad ethics practice, and I think most of people don't do. So we're over talking this. It's fine to certain things to just copy. That's normal, as Magdalena said, like the same methodology you can reinvent, same sentences or same phrases or parts of it. You cannot reinvent. It's like stupid, and that's not a problem. Everyone understands that. Don't do blocks. Don't go from source. Don't quote. There was a question in the chat about reviewing dissertations. So typically, and it might vary a little bit from institution, but typically plagiarism in the from dissertation to a paper is not considered plagiarism. So if you write something in a thesis and then you put that into a paper, that's considered acceptable, because obviously that's your own work, or like typically would be PhD students' work. However, when you go the other way around, when you have something in the thesis, you should be careful how you integrate it into your thesis. So again, like you can put things, but again, plagiarism, I mean, the rules are roughly the same as for the article. So it's okay to quote certain things. Many universities do their own plagiarism tests as well for all the work. And again, so it's about the same thing as you do, but the other way is fine. So from thesis to a paper, it's okay. That's not considered plagiarism.
True. So there are no more questions. So can you proceed further, or?
Yep.
Yeah. Okay.
Yep. But again, yeah, the more questions, the better. We have, and if we go a little bit, here we have time at the end, we'll massage the questions. So the more questions, the better, as I said. Okay, let's move on. Review process. So the next step, when you submit a paper gets in review. So what does happen then? The review is really a service to authors. And the main goal of the peer review is improving the paper. So during the peer review, the errors should be eliminated. The sufficient detail should be provided why certain decisions have been, and then the clarity of the work should be improved. However, something which is too often done, and very annoying is when, and it's totally understandable, you know, you keep working on the paper and someone you have like, I have enough of this, and you just send it in. Well, and you say, oh, they'll tell me what to do. No, that's not a good thing. So if you come to that point, just leave it for a little while and then come back to it. And the reason is peer review is not there to do work for you. It's only to tweak certain things, to question certain things, but not to write a paper or not to improve the paper. So the paper should be suitable for a journal, and that was part of the question, which journal to go in the scope, quality, originality, importance. So all the things depending on the journal. So what happens when you send it to the journal? The first is that typically done at a high level, and that could be done either within the journal editorial staff or by the editor or associate editor. So different journals have a different structure, how they do initial screening. And this, the first decision basically goes into to even send it for review. And that's the questions would be, is this in the scope of the journal? Is the manuscript complete? Is the quality of writing acceptable? So if you fail on any of this, then it'll be just returned, so like, sorry, we're not interested in. And then if it's considered that actually acceptable for a full review, then it goes into the full review. And then the editor, associate editor, or journal staff selects referees, which are independent experts that have knowledge in the field. They have a record of fair and constructive refereeing and are available and have the time. So these are criteria to do. And then you get a decision. So decisions are essentially in three categories. One is immediate accept, and that's very rare. So very, very few papers would just be say, that's it, or fine. So most would come back with requests for modification and revisions. So comments and suggestions come from referees, and the revisions can be then classified either as minor, which might then not go back to reviewers, but often they would, or major, which will definitely go back to reviewers to reassess whether the initial critique has been properly addressed. But the most common decision is actually to reject. So many good journals have rejection rates of over 50%. So if you send a paper in, the most likely is that you'll be rejected. So it may happen quickly after initial assessment or after the full review. But of course, if you do this rejection, then don't panic. That happens. So don't be too afraid. So when you get review back, read referees' reports and put them away for a day. Most often when you say, so like, if this was totally unfair, reviewers don't know what they're talking, and it takes a while to just calm down. It's kind of like directly reviewers kind of attack your esteem in some way. But you should think differently. Reviewers, honestly, in most of the times, with very few exceptions, are actually your friends. They want you to make the paper better. So they're not there to not make your paper publishable, to give you a hard time. Not at all. They just want to make the paper better. So they're actually your best friends because they just openly critique you. You know, sometimes your friends are afraid to tell you the truth. Referees will tell you the truth. Good referees will tell you the truth. And these are the best friends that you have. What should be very important is that you respond to each and every comment specifically. Don't just brush them off. So keep a list of the changes that you made. So very clear, like when you respond, you say, this is what we did, and this is the changes we made in the paper. When you disagree with a reviewer, explain why you disagree. And if only you can, with additional data. If you just go, I think this way, you think that way, you want to go too far. So, you know, because at that time it becomes like, I think this and you think that, and reviewers is in a stronger position than you are. So you should provide some evidence that supports why you think the reviewer. And of course, you have to be very, how to say, just kind and polite. So, and sometimes it happens the reviewer misses a point, but usually that's not the reviewer's fault, because the reason is that the reviewer would not have missed it if it was clearly said and written. So that means that often you would reflect back, even if the reviewer did not get it. It's like, why didn't I write it more clearly that they would catch it? And of course, reviewers, as you know, sometimes are not very careful when they review, but if something is obvious, they will catch it. So you have to make it more obvious. You have to prepare a detailed covering letter with your response, and very importantly, be polite. So don't get into the fight with the reviewers. Again, you don't get in fight with your friends, isn't it? So that's why don't get in a fight with reviewers. So if your paper is rejected, what do you do then? You self-reflect and be critical. Don't be how to say, of course you're not happy, but say, okay, well, probably there is some reason for that. So why is the main reason for rejection? What did I do wrong? Always assume it's your fault. So it's not a reviewer's fault, it's yours. Either you didn't have good enough, either you didn't choose the right journal, or the reviewer missed the point. So it's probably, again, it's all your fault. Do not despair. So treat the referees as a free advice. That's something that's very hard to get. It's like honest advice that can only help you make things better. Maybe not in this paper. Maybe you just at some point you say, well, maybe that's not good enough. I have to move on, but that's what you want to hear. You can rewrite the article, take into account all the suggestions of the referees and resubmit, and go to another journal, for example. But if you really think the review is unfair, which is really, really, really rare. So you would often think it's unfair, but in reality, it's rarely unfair. Then you can appeal to the journal by sending a letter and explain why you think your work did not receive a fair treatment. So, but don't just complain about it, because you don't want to get into the fight with the journal or editor. Sorry. I thought it was a question. Okay, so I'll stop at this point and I'll see if there are any questions.
There was one question in the chat
Yes.
box. Yeah. So
I see. Always found it difficult to fit our dosimetric studies to a standard study design to choose the sample size and statistical analysis. Yeah, the sample size, there are essentially two questions in one. The sample size is very tricky business, and often it's not properly dealt with. There are not enough biostatisticians, and especially physicists think they know biostatistics, and they don't. So physicists just know enough statistics that they think they understand, but in reality is just enough to be dangerous. So when you try to justify the power calculations and sample size, you have to be very careful and not to interpret and not overinterpret. So that's one thing. But most of the time, when you don't have hypothesis testing that would require a statistical test, which would be dosimetric studies often, then it's not really the power calculation, but it's more the accuracy of the results that you quote. And that would be, for example, you estimate uncertainty. Does it mean that your uncertainty has been properly estimated through repeat samples or multiple measures, etc.? So there are essentially two different types of statistics that one would want to have. But it's true that you can like technical papers don't really go well with the hypothesis-driven papers, or studies, which often are in medical physics. So there is a bit of a conflict, and that goes sometimes when you try to put a technical paper into clinical journal. It's like, oh, what's your sample size? Like, no, I'm not doing this. So this is again going back that you want to submit to the right journal. I hope I answered the questions. Otherwise, just repeat. Okay.
Okay, I think we can move to your review of the papers, I think.
Okay. So how to review the paper? And the first question is why to review papers? And reviewing papers is actually very good for you. I think reviewing papers is the best lesson and the best way to know to make you write better papers, because you cannot, the best way to know what annoys you in a paper, what you think you shouldn't do, or how you should write a paper is when you review somebody else, because then the things that bother you can make you think that you don't repeat the same mistakes. It's also a call of duty. So you can't reasonably expect others to spend time reviewing your papers if you don't review theirs. And this is really important that we keep the literature free of errors. And you should think about it this way. So for every paper that you review or that you publish, has typically would be seen by, let's say, 2-3 reviewers, or if you had to go to more than one journal, 4 or 5. That means that for every paper that you publish, you should kind of like review the same number of papers to make it even, roughly. So so this is roughly the weighting that you would want to have, how many papers you want to commit to reviewing. It's very important to review and try to volunteer, because it's really good practice. It also helps career advancement. They're expected and seen as evidence of your standing in the field. Often, if you ask, the journals would be happy to provide the evidence of how much you've been reviewing, and that's something that could be that's something you could use, in your career. And of course, it's also a fun part, because then you start following the field, and that's how we follow what's happening. And so it also has educational components. But before you accept a review, you have to be, again, very critical. Do you have the necessary expertise? If you don't need to be the best expert, but you should know enough to write an authoritative review. If you have a conflict of interest, then you should decline it. Rarely it happens, but it could happen. You could you get a paper from the friends, or even, I got papers from my former students, etc. And of course, you don't want to review those. You have to be very honest to report within the requested deadline. If you cannot, tell the journal right away. This is the most frustrating part of the review process for the journals and for the others. Imagine that you are waiting for the paper to come back, and it's just reviews are not in. You're really angry, isn't it? And it's the same way when you're delaying the review to the others that had sent that paper in. So the same way how you hate waiting for the reviews, the same way the others that you're reviewing paper are waiting eagerly to get reviews. So try to do it. And if you cannot, it's better to say, sorry, I cannot do it. And then the journal will find an alternative reviewer. And then also you should be willing to review the revised version if necessary. And it's very important, responsible commitment, because the others will respond to your critiques. And that's something which is very important, that if you do initial review, then you see if the others are responding fairly to you. It's very hard for somebody else to say, yeah, are you happy now or not? You know whether you're happy and whether the others have done the job. So when you ask whether a certain paper is worth publishing, what do you think are the questions you should ask? It's actually the same questions that you ask yourself if your paper is worth publishing. Significance, novelty, validity, and impact. Same thing that you send in, that's when you get it for the review. What should you do in a review? You should be unbiased and objective. You should be constructive and respectful. So as I mentioned earlier, when you get reviews, consider reviewers as friends. So when you accept reviewer's task, you are actually on the author's side. You are in the position of being author's friend. So you just want to improve the paper. You try to do the best what you can to make that paper better. It's not to make you don't want to be nasty. You're not nasty to your friends. You just want to be as helpful as you can. And then again, repeat, send your report on time. If you cannot be, something happens, tell the journal so the journal knows what to do. Follow the instructions. And of course, contact journal if you have any questions. And a very important thing when you start reviewing, before you go into the details, is that you form an opinion about ultimate decision. As I mentioned earlier, there are three main categories: accept, revise, reject. So before you start writing your review, you should already know what would be the fate of this article. Most often, journalists don't want you to put the decision in the written review, but they will ask you in a separate question, what's your recommendation? So, however, your comments, they are typically split between general and specific comments, should reflect your ultimate decision without actually stating it. So if you are just rejecting, there is no reason to write specific questions. You just say general comment and say, this is what it is, I'm rejecting. And these are the reasons why I don't think this is worthy of publication. You might still add specific comments because, as I said, as a friend, that might be helpful, even if it's rejection, for the authors to improve the paper. If you think that's rescuable paper, so you just think it's not the novel, if you think that something is wrong, you can say, I don't think this is ready for publication, but you might want to think this and this and this. So if it's more general, it can be in general comments. If it's more specific, it's like, maybe this figure is not good, maybe you want to replace, or things like that. So this is an important one. So you need to form the decision before you start. What you should not do in a review. The first thing is you should not do nothing. If you're unable or unwilling, then just tell the paper. If you agree to report, but then you fail to send it in, that's a very bad practice. That will hurt you, because the journalists typically keep tab on your refereeing performance. You should not write a review without specific evidence. If you recommend accepting or rejecting paper, it should be clearly based on evidence, literature, why you think so. If you make statements without clear explanation or evidence, and have a one-line review, this is a grad-bait paper. That's totally unacceptable. Also often happens in the review when you have a conflicting report. Some parts say, oh, this is great, and the second part is like, this is not great. Or very frustrating is when you change your mind during the revision. So typically, you have to stand by your first assessment of the paper. If you ask authors to do something and the authors do that, then you cannot complain anymore that they didn't do something else. You didn't ask them for it. So during revision, it's really important to focus on whether authors addressed your initial comments, not to come with new questions, because that's too late. It just leads into frustration. You don't want to personally criticize any of the authors, and don't spend excessive time correcting English. So focus on the studies itself. Okay, this brings me to the end, I guess, of the lecture. So in summary, but we'll open to the question. So I think writing papers is a critical part of scientific life. You know what you did, but nobody else will know if you don't write about it. So writing papers is a critical part of scientific life for everyone. It's very important that when you write papers are very self-critical, and you question yourself about significance, novelty, validity, and impact. Similarly, as writing papers, reviewing papers is a critical part of scientific life. Try to make most of the scientific work that somebody has invested in. Always remember that most of the papers require a lot of work, a lot of commitment, especially from junior authors. So you want to respect that. But again, when you judge them by significance, novelty, validity, and impact. And both of the skills that you need to master. And of course, the best experience or the best teacher is actually experience. So the more you write, the more you review, the better you get at writing and reviewing the papers. With that, I'd like to stop. So of course, we have questions, and I'll be happy to answer any questions that you might have. Let's see if there's any questions.
Yeah, just I will put two questions to you, Jaraj. As an associate editor of the few of the journals, I know how difficult is to find the reviewer and maintain the timeline. Many a times, getting a reviewer is a very difficult thing. It delays the response. doesn't come for even 15 days, reminders. Sometimes the reviewer accepts, and then second reminder, third reminder, then he withdraws, it gets delayed. So if one is sure about reviewing and he has a time, he should take 2 or 3 days and then accept that, yes, I want to review, because the journal send the abstract and the paper to the reviewer. Sometimes we find difficulty also that generally journals two reviewers, independent reviewers, and when we get the report, one reviewer says, yes, good paper, accept this thing. Another, sometimes it happens, it's not always. Sometimes blatantly the another reviewer says it has no value, it should be rejected, and then becomes a task difficult, because it has, the paper has gone through the editorial review and then has been sent to the reviewers, and here a conflicting report. So what I do is send to a third reviewer, get the comments, and then club up all the three, put my mind on the paper and this thing, and then make a decision of editorial decision. So that is how we go. Any comments about this procedure, and any comment about the reviewer accepting, delaying? And a lot of time it goes. Sometimes 2 to 3 months also are spent in getting the reports.
Yes, I spend quite some time urging everyone to, only accept if they know they can do the job. And then when you accept, you try to do it within the timeline. This is really important. And like, I think for the journalists and editors and for the authors, that's the most frustrating part, is just waiting and waiting and waiting. And like, the best advice is like, as much as you hate waiting for your paper to be reviewed, that's exactly what happens if you're delaying a review to others. So be respectful to others if you want others to be respectful to yours. That's essentially. The difficult part of the conflicting reviews, which happens, I say, relatively frequently, more often than you think, and it causes a lot of frustrations with the authors as well, because like, yeah, this reviewer said that, and usually say like, he said it's a good one, but then the negative was like, but usually, then more likely than not, there will be the negative might overweight, because often what happens, I would say more often than not, is that the positive review has not seen something that's wrong with it. So more often than not, the negative will dominate, because it's something that's probably more likely wrong with that needs to be addressed, but maybe just a matter of the opinion. And in that sense, at that time, there's nothing else that you can do, as you said, is like you have a authoritative decision by the associate editor or whatever, or third reviewer, or somebody makes a decision. And then the best thing what you can do is not to complain that somebody said that's a good one or whatever. You just go with that decision and try to address as best as you can all the critiques. So don't try to argue that, yeah, there is conflicting. Yeah, it happens because people see things differently. Some people read more carefully, so some are more experts than others. So always take everything as a positive and just respond and don't complain. That's my best advice to do as on the receiver end. And of course, but it is a difficult, like for an associate editor, that's why associate editors or whatever, editor-in-chiefs make the hard decisions. So I have to do them almost daily. And yeah, and that's the part of life.
Joke it has come that after multiple reviews, the tiger had changed to a dog or some shape. Neither it's a dog nor a dog. The paper becomes that, multiple reviews and things, and then the comments. Sometimes the author loses what he wanted to really put into if all the comments are taken up. So just now I would like to introduce, thank you, Robert. Again, you are there for the discussions here. Just let me introduce Magdalena just if I pronounce Bazalova Carter, she's associate professor at Canada Research Chair in Medical Physics at University Victoria, Canada. Postdoc instructor at the Stanford University, Palo Alto, USA. PhD at McGill University, Montreal. Funding from the government of USA and Canada, a lot of projects she has got. Funding from the industry, Varian technologies, many technologies she has got. Grant reviews she's doing for the Natural Science and Engineering Research Councils, Canada, Research Chair, Canadian Institute of Healthcare Research, American Association of AAPM, American Society of Therapeutic Radiation and Oncology, German Research Foundation. So he's a grant reviewer and therefore a perfect speaker for the grant writing applications and projects. Research and radiation therapy. She has an interest in FLASH, specifically fractionated radiotherapy, small animal radiotherapy, cost-effective radiotherapy, experimental, and the simulation work. Research in imaging, photon counting, and X-ray fluorescence imaging. She is expert of that thing. So with this brief introduction, I hand over the floor to Magdalena for her talk about the research funding, how to get about writing paper, because once you have a funding project, you generate a lot of data, so publication things. So how to write the funding projects. Thank you for sparing time at this late night. So the floor is yours, Professor Magdalena.
Okay, thanks, Arun, for the invitation and for the introduction. And I'll be talking about how to write and review grants. And actually, there's a lot of overlap with what Robert was saying as well. So you'll hear some things for the second time, but hopefully this will be something new as well. All right, so we'll be talking about money, of course. Somebody's not muted. Okay, hopefully it'll work better.
It's visible, no problem.
No worries. So we'll be talking a lot about money and how to get it and what to do in order to get it. So this is my disclaimer. I do have current funding from NSERC, Canadian Tri-Council, from the Canada Researchers Program, University of Victoria, and Redland Technologies. And this is very relevant to this grant because it's kind of tells you where I'm coming from as well. I must say that I have gotten very lucky with my grant applications. So basically, since I started my independent researcher position in 2015 at the University of Victoria, every single grant that I have written, I have received. But I also must say that I am pretty picky about what I apply to and when I apply. So it's very similar to what Robert was saying with papers. You really want to make sure that you have put a lot of effort into writing a paper because you don't want to make the referees angry about your work because you have not checked your references correctly and you have lots of typos in the paper. So you don't want to do that for a grant application either. In the process, however, I get help from many researchers, and this is very important when you're writing a grant application. It's much more important than for a paper that you're getting feedback from others on what you're proposing and how it's put together and how consistent you are. I'm not sure if you all are writing grants, but I hope this presentation will be useful at least a little bit to everybody who's in the audience now. And I must also say that some slides and ideas are borrowed from Christy Brock from MD Anderson Cancer Center, and those will be clearly identified in my talk. Okay, so where am I coming from? Similarly to Robert, I'm going to give a brief overview on my grant funding. So I get my first independent research grant from the American Association of Physicists in Medicine, or the AAPM, which was the AAPM research seed funding in 2012. So I got $25,000 and I was very excited about that. You see that this is not a lot of money, but it was a lot then, and it definitely opened the door for many other funding later on. And actually, as a matter of fact, I had prior to this, I applied to an NIH grant and I didn't get it. And I reapplied, and because one of the comments of one of the referees was that I should get funded because I have already proven that I can get independent funding, and he was referring, or they were referring to this AAPM seed funding. So basically, it's really difficult to get the first grant, but once you get that, it's going to be easier to get the following grants. I have held 16 grants in either Canada or the USA as principal investigator or co-investigator. Principal investigator is often abbreviated as PI and co-investigator as COI. And these were received from either government and industry. And so far I've received about 3 million of research funding, which was spent mainly on trainees' salaries and equipment. And I think this is very different depending on what country you're in. And I have reviewed grants for Canada, US, the Netherlands, and Germany so far from what I remember. So what is actually grant funding? Well, perhaps everybody knows, but maybe not everybody in the audience knows, depends on your stage of your career. So it's basically money given to researchers so that they can work on typically a well-defined project. Here in Canada, we basically have funding that doesn't have to go on to a well-defined project, even though you still have to write it up on a project. You're basically reasonably free to do with the money whatever you want, as long as you are progressing with your research. Funding is typically distributed in a competitive fashion based on peer reviews, very similar to what we do with papers. You know, your grant is sent to a review team, they look at it, they evaluate it one way or another, depending on the granting agency. And you hear back from them whether or not your grant will be funded. It might be funded, you know, at the same level that you asked for, it might be funded at a different level, and we'll probably talk a little bit about that as well. But it is a competitive process. But it's definitely not perfect. It's the same way peer review for papers is not perfect. But it's not that when you apply, you get the funding. No, you have to be one of the best proposals in the pile. And what are the, where can you get your funding from? Very often granting agencies are part of the government. So for example, in the US, it's the National Institute of Health, the NIH. In Canada, it's the Canadian Institute for Health Research, or CIHR, but grants can also be awarded by private sources, such as the Bill and Melinda Gates Foundation, or by industry. Darian definitely gives out grants. I'm sure Electa does give out grants as well. So you can apply to these different institutions and get funding for your research. However, all grants are different. So I'm not, of course, familiar with Indian grants, for example. I'm familiar with maybe grants from Canada, from the US, maybe a little bit now from the ones that I've reviewed for in Germany and in the Netherlands, but perhaps some in the Czech Republic. So keep in mind that whatever information I'll be giving, it's not necessarily for your particular grant that you might, or granting agencies that you might have in mind. So different countries have different funding mechanisms, as I described already. And even for me, who have spent time in the US and in Canada, I actually see quite clear differences between these two countries that are very similar in many regards. There's also a huge spread in the amount of funding you can get. So you can probably get hundreds of dollars depending on the country you're in, but you can get for example, $1 billion if it's a huge project, given by the government or given by the Department of Energy, for example. So keep that in mind as well. The complexity of the project scales with the amount of funding that you should be getting, right? If you're looking at something very simple, evaluating a new piece of small equipment, you're probably not going to be getting millions of dollars. If you're proposing to cure cancer, you will probably be needing a lot of money. So that's something to keep in mind as well. And in general, I would say, start with smaller projects, because if you're going to be applying for $10 million, but this is your first proposal or first independent funding, you're probably not going to get it because you have not demonstrated that if you get any amount of funding that you will achieve any goals with it. So that's important. The amount of funding also scales with the number of pages that are required to describe the proposal. Thankfully, this is not linear, because if you're applying for hundreds of millions of dollars, you don't want to be writing hundreds of pages, but you might end up with hundreds of pages in the end anyway. And the grant duration also varies. So typical lengths are 1 to 5 years, but they can be shorter and they can be longer. One thing to keep in mind, and I'm actually not sure if that's the same in all countries, but I think especially with COVID, it's probably more typical. Extensions are usually possible. So if it's even for us in Canada, even though we get 1 year grant, we actually can typically get a 1 year extension on it. We're not getting more funding, but we can get more time to complete the work that we promised we would do. And notes that large projects require a lot of time, of course, to complete, but also typically large teams. You cannot be, telling people that you will cure cancer, but it'll be just you. That's usually how it's usually not how this works. So you will have to assemble a big team and you have to describe why this team is good to solve this problem and what people will be doing on your proposal as well. So why should you apply for grant funding? Again, it might be obvious, it might not be obvious, but there's different motivations why people apply for funding, and it's sometimes shows in the proposal as well, and perhaps is reflected by the success rates as well. So the ideal scenario is that you have a great idea that will improve the lives of millions of cancer patients, right? That would be great. Unfortunately, that's not often the case. So very often we have an idea that might one day improve the lives of some cancer patients, and that's still valid. So for that, you might need to try to build a device, renovate some space, you might need to conduct a preclinical study or even run a clinical trial. So those are all valid reasons why you would be wanting to apply for funding. Here in Canada, we often have to apply for funding because we're expected at my university to support trainees, at all levels, from undergraduate students, graduate students at the master's, PhD level, postdocs of research assistants. That's probably not a noble reason why we are applying for funding, because we would like to be solving a problem in the medical physics field or any field you might be in. And for that, we might need trainees to do the work. But the noble goal should be, again, to help cancer patients. There's two even less noble reasons why people are applying for funding. You have to get grants to get promoted. And very often we see that that's the case. It was the case for me as well. And even less noble cause or reason is that you would like to increase your salary. And that might or might not be the case at your institution or in your country. So for example, in the US, this can happen, that you can basically be increasing your salary if you're getting more funding. In Canada, that's not the case. I can get, hundreds of millions of dollars, but I see no benefits to my salary, at least not direct benefit to my salary from the grant that I'll be getting. Actually see some chats, maybe. Okay, excellent. So how do you apply for funding? So again, the ideal scenario here is that you have a research idea, so something, okay, I do know how to cure cancer with radiation, and you find the granting agency with the appropriate call for proposals. So there's many granting agencies, they all focus on different things, or at least slightly different things, if not completely different things. You have to find the appropriate granting agency so that you can pitch them the idea and you can get the funding, and they'll be all excited about it because you're curing cancer. Unfortunately, this is also not always the case. So what often happens is that there's a new call for proposals. Everybody knows about it. Granting agency, that happens very often in Canada. The government realizes that they have money. It's the end of the fiscal year, and they start a new start a new call for proposals, and then they want to distribute this money somehow. And then people are looking at these calls of proposals. Everybody's getting emails. It's posted on social media. And then you have to basically sometimes try to tailor your research, spin it a little bit one way or another so that you can apply for this source of funding. Again, this is not ideal, but this very often happens. And we have seen that quite a bit with COVID, when, in 2020, there was a lot of research funding put into the research of COVID, which was very reasonable, of course, and made a lot of sense. And people are, trying to spin their research in such a way that they can access this funding. As I mentioned already. So depending on the granting agency, you can have they can have different institutes. So that's, for example, the case for the National Institute of Health, NIH. They have, for example, the Cancer Institute, the NCI. They have an IBIB, which is more like geared towards equipment. So you need to make sure that whenever you apply to a granting agency, this is actually a good fit for your proposal. And sometimes it's not clear. It's like basically submitting a paper to a journal. You might, think that there might be 3 journals that might be pretty reasonable, but one of them is probably a little better than another one. So it's very similar game, except the number of journals is much greater than the number of granting agencies. But you always want to make sure that this is a good fit. And there may be different study sections as well. So you might have to be able to select the appropriate group of reviewers really that will be evaluating your grants. Because if you are putting it into a group that's doesn't do that work at all, the reviewers will basically not do the justice to your work, and you definitely don't want to end up in this situation. As I said, make sure that you apply to the appropriate granting agency or institute. And one thing that you can do, there should at least be some contact information of people that will be involved in the review process. And you can always email them or call them up and ask them, this is, my proposal, send them your, specific aim space, send them the summary of your proposal. And you can ask them, okay, is this a good fit? This is what I'm trying to do. Is this something that your study section, your study group is interested in? So certainly do that. And of course, you can ask your colleagues, in the same department, they have submitted grants. Do you think this would be a good fit? They should be held at your university or at your hospital with grants as well, hopefully, or in your company if you're working for a company, if you can get grants there. So how to write and review is really the topic of this talk. But you have to keep in mind that all grants are different. So what I'll be trying to do here is to present some key ideas about what you should follow. And again, there's a lot of overlap with what Robert was saying about writing papers and reviewing papers. And this is something that Robert said as well. So I was, smiling about that because I have basically the same idea in my talk. Experience with the review process immensely helps with the writing process. Similar with papers, you want to review papers because you want to learn from what others are doing, what you like, what you don't like. But you want to learn from the reviewer's perspective, which is very different than the perspective of the writer. So you see this work for the first time, you really want to make sure that you understand it. So unfortunately, you will likely not be invited to review for an agency unless you have received funding from them. So what I see this is a little bit of a chicken and egg situation. You will be better at writing grants if you can review them, but you won't be able to review them unless you basically receive funding from the agencies. Okay, so are there any questions so far?
In the chat box, there are no questions. So I think you can proceed and then we can have a discussion at the end, I think, or in between. Okay,
okay, sounds good. So, there's, that you want to be writing a grant. There is a call for proposals. That means that you can submit a grant. But one thing to note here also that granting agencies typically have deadlines. So for the NIH, maybe it's 2 or 3 times a year. For CIHR, it's twice a year. So you want to make sure that you adhere to these deadlines. And that's, I know it's very different from submitting a paper because there's never a deadline and sometimes you wish there was a deadline. So you make sure that you finish your proposal well before the deadline. If you're at a university and perhaps even at a hospital, there'll be likely somebody at your institution who will be reviewing your grant for completeness to make sure that whatever you're submitting will be acceptable and accepted by the granting agency. So you want to make sure that everything goes smoothly and then you're done with your proposal well ahead of time. Again, that never happens, but it would be nice if it did. So if you're looking at this call for proposals, you want to make sure that you understand what the granting agency is looking for. So for example, is this a call for proposals for clinical applications, right? If you're doing some basic research, this granting agency and this specific program will not be funding your basic research if they're asking for clinical applications. Sometimes the call for proposals could be only geared towards academic or clinical institutions, or maybe one or the other. So you want to make sure that you actually fit the eligibility criteria, and you can always email the granting agency. And sometimes you actually have to have very often in Canada, we have to have collaborations with industry as well. So you also want to make sure that you have an industrial collaborator on board, and they want to support you. Sometimes they actually have to put in money as well. If they don't have to put in money, just some time, they're usually okay with that. But if they have to put in some direct, or their contribution includes some direct cost of research, they might be a little more hesitant. So you always want to make sure that you start thinking about this well ahead of time if you have a chance to do that. The thing that you don't want to do is to be working on an application that has 100 pages, and then you submit it and they tell you, actually, now this is not a good fit for our granting agency. And then you have to wait a year for another deadline to come by. So that's something you definitely want to avoid. One thing that I would tell people, and similar to what Robert was talking about papers, is to look at evaluation criteria. Here in Canada, we have it very clearly written what the evaluation criteria are, and you can actually be writing your proposal, with the evaluation criteria in mind. So I highly recommend reading them, and reading them very carefully, because there might, if you're the reviewer, you might be going through the evaluation criteria, one by one, and seeing, okay, does this check all the boxes? If it doesn't, you're gonna get lower score than if it had checked all the boxes, which might be very easy for you to do. So what you need to check also, what are the components of the grant application? I still remember when I was writing my first NIH grant, I was so relieved when I finished my 12 pages. It was great. And then I thought I was gonna be ready to submit it, and I realized there's like 5 or 6, 7 more documents that I had to submit, such as describe the institution, put together my bio sketch. We'd have to have a statement about myself, not just publication record and whatnot. I had to submit letters of recommendations, to submit about conduct of research, just making sure that I will not be plagiarizing. So all kinds of other documents that I had no idea had to be included, and took up a lot of my time. So the other thing to note here, that it depends on the granting agency, but in Canada, sometimes our grants are rejected purely because we are not following the formatting rules. So if the margins are not, as large as we were told them to be, and if the font size is slightly different, then our grant can get rejected just because of that. You also want to make sure that you submit the correct number of pages. So if your last paragraph is on page 13, but you can only submit 12 pages, it'll get cut off. And again, that's not going to just bode well with the reviewers, and your grant will not score very highly. So in terms of the components, this is just a slide from the NSERC, the Natural Sciences and Engineering Research Council of Canada, discovering grant application. And basically the evaluation criteria tell us that we'll be evaluating on 3 different components of the entire grant proposal. It is the researcher. It's really all about you. It's the quality of the proposal, but also of what we call here HQP, which is the highly qualified personnel. So have you trained people, what they have done afterwards, what did they do for you? So what are the components of the application? So for the researcher, of course, is your CV, and here we call it Canadian Commons CV. You have to describe your most significant contributions. So it's not just the CV, but you have to submit a couple of pages on how did you contribute to the field of medical physics. You can also attach leaves of absence if you're on maternity leave or on sick leave for a longer period of time that affected your productivity. You can tell the review panel as well. And of course, you have to submit the proposal, and most of this talk will be on the proposal. That is the actual proposal, but also budget justification, and also references. And you want to make sure that this is all complete and it all matches and is consistent throughout the entire grant application. And for this highly qualified personnel or trainees, we have to talk about past contributions to trainees. Again, what have our trainees done? But we also have to very clearly describe what our training plan is. How are we going to be training people if we get funded? And again, Canada is very focused on HQP, or on training students, postdoctoral fellows as well. So this is just an example that, you might be focusing on just on the proposal, but there's many other aspects of an application depending on what granting agency is. And it can be, 2 other documents, but it can be 10 other documents. So something to keep in mind. So what I think a grant writing workflow would be, you have to have a project idea. We talked about that already. You have to have something in mind, something that you will be asking for money for. So I'd say, then you work through the goals or aims of your proposal, what this will be. At the NIH, it's called specific aims. I would say, could be just bullet points. You have to know what you will be doing, or hypothesis, perhaps, if you can come up with one. Then I say you can write project proposal. Then you write supporting documents, which we talked about. Then you look at your evaluation criteria, and then you adjust your project proposal to address all the evaluation criteria. You also adjust the supporting documents to address the evaluation criteria. And I say, what you do next is to send your documents to your peers to look them over, and make sure that you give them a lot of time. If somebody's famous in the field, like Robert, you want to send him your proposal, but 10 other people want to send Robert their proposal, and Robert's also working on his own proposal, he's probably going to be very busy. So make sure that you give your peers enough time. And if you can send your proposal to multiple people, that's always better. You might get some interesting ideas and perhaps conflicting ideas as well. But definitely this is a critical step for writing a grant. Send it to your colleagues. Then you go revise your project proposal, supporting documents as well. And finally, maybe you go back and you proofread your document. Typos are not a big deal, but if you don't have them, it's much better than having them. So making sure that there's no typos, that the grammar is correct. You can send it to a service to look it over if you want to. But again, sending it to your friends, to your spouses works actually quite well. Then you make it perfect. You really need to make your proposal perfect. Then once you're very happy with it, you spend a lot of time on your proposal, you submit it. And of course, after you submit it, you do find some typos, but that's a part of the game. So this is sort of how I see the grant proposal project workflow. And just gone through that. So let's just talk about the key components of a good proposal.
Can you unmute? Somebody speaking in between? I think. Continue.
Are we good? Okay. So what are the key components of a good proposal from my point of view? You have to have a great, or at least very good, innovative idea that affects many patients. You have to, I think this is perhaps the most critical one to me as a reviewer. You have to provide good, clear, and concise story. It has to be actually a story. How I'm going to make the lives of patients better. You have to include the current literature. You don't want to be omitting anybody's research, because these people might actually be reviewing your work, and that's not going to work well for them. And you have to well describe a feasible approach. If you well describe something that's not possible, it's also not going to work really well. So the approach has to be feasible, and also has to be feasible within that amount of time that the grant is giving you. You should be showing some preliminary data as well. If there's something that is a completely crazy idea and you have no preliminary data, it's just going to get killed right there. You have to convince the reviewer that you're the best person to complete the project. And then if it's a larger project, you have to make sure that you have assembled a great team with the appropriate expertise. You have to describe it, because the reviewer might know nothing about you, might know very little about the research area, unfortunately. So you have to convince the reviewer that you're the best for the project, and this is a great idea, and it's going to change the world. What we focus here on in Canada is equity, diversity, and inclusion. So you want to describe that as well and make sure that you take this into account. You should provide a reasonable timeline as well. You don't want to be saying that you will be, you'll be doing something in 1 year, when in reality, it's going to take you 5 years, and the reviewer also knows it's going to take you 5 years, and it's just going to be seen as too challenging. It's always nice to provide nice and legible figures. If they are too small to see anything on them, it's also not going to work. And if you can, provide a proposal that does not contain any typos. So you're writing your own project, this is what you're describing, but you're writing it for a reviewer. So it's very important that you keep the reviewer's point of view in mind as well. And you basically can assume that the reviewer, well, they're a scientist, they might know very little about your research area. So everything has to be very well described. So here we're starting some slides from Christy Brock, just making sure that everybody knows that. So how about your research proposal? You have to love your grant. And if you love it, I guarantee you it's going to show you in the writing. You need to write and submit the grant that you want to do, because guess what? You might actually get it and you will be stuck to do the work. So make sure that this is the work that you want to be doing. Do take advice and suggestions from other people, make modifications, but do make sure that you're basically writing your own grant. Show that you're passionate about what you're doing, but make sure that you're not writing somebody else's grant, or don't chase what you think the reviewers want to fund. That this is always a bad approach. You might be thinking about that, but depending on the granting agency, if you don't know them very much, this is not really going to be an issue. What means no typos? So that means that your spelling is correct throughout your grant. I probably have some typos in this presentation, but you want to make sure that there is no grammatical errors, or very few at least. If it's full of typos or misspellings, I think that's a good word for a typo, then it's just, again, not going to work well for a reviewer. Okay. So what I think a research proposal should be a very nice, easy to follow and consistent story. Don't jump from one thing to another and then back to the one thing, because reviewers don't like that. The writing style is also important, maybe also very important. So if you can, polish it and not necessarily use fluffy language, but nice language, that's always valuable. But of course, this has to be scientifically correct. I would say absolutely avoid the use of many abbreviations. If, in one sentence, you have 7 abbreviations for 7 different things, that mean completely different things, that's not good. It's not easy to read. And if you have to spell it out, spell it out. If you can write in simple terms, if you don't, you cannot write, you don't have to write all the proteins that you will be studying all the time. So abbreviations, too many abbreviations are very difficult to read. Absolutely use figures, but use them cleverly. You don't want to be, if it's a 12-page proposal, you don't want to be spending 3 pages on just figures. You have to make sure that, there's enough text to describe the figures or captions in the figures, and the figures have to be legible. Font sizes have to be large enough so that people can actually see them. I highly recommend using section headings, as well as highlighting key points and statements. Just use bold text, use italics text, but make sure that some parts of your proposal are highlighted so that the referees can basically, if they read the proposal, they can go back again and just read these key points, and they will get the full story second time they read it. Skim over the grant. Don't make reviewers do a lot of work. We as reviewers don't like to do a lot of work. If it takes forever for me to understand what you're doing, if I need to read the grant 3 times, it's probably not going to get funded, because I'm not going to be a very happy reviewer the 3rd time I read it. And we'll talk about reviewing as well. And reviewers do want to understand your research proposal. They want to understand it after by one reading. Then you don't want to make reviewers feel like they're not smart. So you have to describe it in such a way that they understand your proposal after the first reading. And this is an important slide as well. Know that the first impression of your grant is very important. And this is especially true for NIH grants. But the first impression is given, for example, in your research summary, in your introduction section, or in your specific aims page. And that's the important one in NIH, it's the specific aims page. It's basically a page that describes a little bit of the introduction, why you are doing it, perhaps a little bit of the innovation, some of the steps, and what are the goals of your proposal. And this is an extremely important page. I'll talk about that on this slide as well. Because most reviewers will tell you that their opinion is formed when reading the specific aims page. So the first, page of your proposal, they will make up their mind whether or not they're reading to kill or reading to fund the grant by the end of the specific aims page. Okay, so make sure that the first impression is good, that it's clearly described what you're doing, clearly described the goals of the proposal. And what you do, and I'll be talking about that multiple times still, you write and you revise some more, you get opinions, you revise your proposal again, you read and you revise, and make sure that the first impression is a good one, because you will never get a second chance to make a first impression again. So make sure that the first impression is good in whatever format your grants might be. So what are the key elements of the first impression? You need to convince the reviewer that there is a real problem. It is either catastrophic or impacts a lot of people. So for example, solving a transient grade 1 toxicity that occurs in 2% of the population isn't very impactful. Might be good for a small grant, but if you're looking for $1 million, it's just not gonna be above the threshold of importance. You have to state facts with numbers and with references. If you're saying something that I cannot look up as the reviewer, I'm just not gonna believe you. So if facts are stated without any citations, I'll be very hesitant to actually believe them if I don't know that information right away. So you need to demonstrate that some work in that area has already been done, but there are some limitations. If the work is yours, that's great. That works out really well because you already have expertise in that area and you can show that by publications typically. But if it's not yours, you have to be very careful how you frame the limitations, because the people that will be reviewing your grant might actually be the people whose work you're referring to. So there's to make a clear line between disparaging others' work and indicating the limitations. So some of the examples of limitations is there limitations in the translation of the research? Is there limitations in the adoption of research? Or has the past research been only demonstrated in simpler scenarios and they were, for example, not clinically relevant, and you'll be applying the same ideas and perhaps improving them in a clinical scenario, in a more complex case. Okay, so you also need to convince the reviewer that you're the best person to do this work. So you have to talk about your preliminary work. If you haven't done any preliminary work on this particular project, it's probably not very good, but you should at least talk about your work that you have done on some related research. You need to show them what is unique about your team and what is unique about your institution. For example, you need a radiation oncologist, you need a medical physicist, of course, that would be you need a radiobiologist, and you need an accelerator engineer to get, to complete this project, and nobody else has thought about this. So this is unique about your team. What is unique about your institution? For example, you might be the first institution that has that particular piece of equipment, and you're trying to run a clinical trial on this piece of equipment that nobody else in the world has. This is very unique about your institution. You will be more likely to get funded because of that. You want to highlight always, a number of factors that make you perfect for this work, or that makes, how your work is innovative, for example. So you want to highlight very specific things why you are the best person to conduct this work. And you should provide long-term goals and a hypothesis. Should always be the case. And you should also summarize why the reviewer should be excited about the potential for your research to be successfully completed. So you want to make sure that basically the reviewer is on your side when they read your proposal and they actually fight for the proposal when the time comes. So this is very important. You have to talk about proposal significance. So what are the 5 key things that makes this work significant? So you can put that, it doesn't have to be 5 things, but it's good when it's 5 things, again, depending on the size of the grant. Make sure that you don't bore the reviewer with repeating the same information. One thing that I really dislike, if you have different components of the grant and you're repeating entire paragraphs, reviewers really don't want to see that, and it's definitely decreases score when I review. Bullets and pictures are great for really anything. You want to be concise, straightforward, be readable, be factual. Again, if it's a nice story, that's always a plus. You need to focus on the important pieces of project significance. You have to logically walk the reviewer through the pieces of the puzzle so that by the end they think, why isn't somebody doing this already? It's very important, again, that you get the reviewer excited about your work. In the US, with the NIH, you have to submit proposal or research innovation. It might not be necessary to describe for your granting agency, but it's a good idea to include what's innovative about this. You should put again together a number of pieces of innovation. Again, you can use bold text why this is an innovative idea. Bullet points are also good. And one thing that I thought was kind of interesting that Christy put in here is that this is a great place to have key sentences that the reviewer can copy and paste. We'll talk about this when we talk about how to review grants, but basically, we have to summarize a grant when we are reviewing it. And here in Canada, we are basically told to absolutely not copy and paste text from the grant proposals, but apparently this is a welcome idea at the NIH, which is interesting, and I completely agree with that. And you definitely don't want to be wasting space ever in your proposal by stating statements that really mean nothing, such as this research is highly innovative. That really tells me nothing, right? You have to give me the proofs, the points why this research is innovative. Don't tell me that it's innovative. I'll make my opinion about that once you give me the proof that is indeed innovative. Okay, so how about approach and methodology? So you want to show, how great this of an idea is, but you also need to tell people what are you going to do and how exactly are you going to do things to achieve the goals of your proposal. So this you do in the approach or methodology or materials and method sections that you would call for writing a paper. So the message from Christy is here that think of your aim as a recipe for a graduate student to follow. So you take this data, do this process, make this measurement, do this analysis, etc. Unfortunately, grant proposals are not, as many pages as a PhD thesis, for example. So you have to be quite concise, and you have to basically choose what exactly you'll be putting in your proposal. How detailed can you be, or how detailed should you be? And basically, it's a tricky balance here because you have to put enough information for the expert reviewers, somebody who does exactly the same thing, understands every single little detail of your proposal. It has to be enough detail so that these people trust you, even the experts trust you, but it also shouldn't be too detailed so that people who are not experts in your area of research will get completely lost. So there's a fine line between these two aspects of describing approach and methodology. If you have preliminary data, absolutely incorporate them. There's always fine line between, having enough or too much preliminary data. You might be asking for money for something that you have already done. Of course, that should not be the case. You have to consider statistical analysis as well, making sure that your sample is large enough to be able to draw conclusions. One thing that's good to do, and it's required at the NIH, it's not required in Canada, are potential pitfalls and alternative approaches. If you have 3 different goals of your proposal, but goal 2 and 3 depend on successful completion of goal 1, which might actually not be successfully completed, you need to provide alternative approaches to make sure that the reviewer understands that if you stop at aim number 1 or goal number 1, that you will be able to complete the research with some alternative approaches and ways to go around your failure at aim 1. And you should also mention expected outcomes. If you can use a graphical abstract, this is not quite graphical abstract. This is a figure from my proposal when I was basically showing the pieces of puzzle that we need to get put together in order to translate flash radiation therapy into the clinic. And I said, okay, these are the pieces of puzzle that I am working on. And that's what our granting agency wants to see. But if you have a graphical abstract that shows you exactly what you will be doing, to the point that when the reviewer looks at it, even without reading the proposal and understands what you're doing, that's outstanding. You should definitely work on that. But granted, all these things, these graphical things, take a lot of time to prepare. So make sure that you do have a lot of time. So remember, the grant proposal is not about the research that you're proposing. It's also about you. As I mentioned, if your very first grant is a 20 million grant, you're probably not going to get it because it's your first grant, and the reviewers might not trust you that you can manage even that amount of money. So you have to attach a CV in the appropriate format. In the NIH, it's for BioSketch. In Canada, it's Canadian Common CV. whatever it might be for your country or for a particular granting agency, make sure that you attach CV that is complete. It's very important that you don't omit some information. You might think that invited talks might not be relevant. You don't want to be spending too much time updating your CV. You can again get your points deducted for not completing your CV. So you don't want this to happen. It does take time, make sure you have it. And use the dedicated space to really sell yourself. The referee might not know you, so you need to tell them everything about you that's relevant to the proposal that will make them believe that you can lead this proposal to a successful completion. So you have to sell yourself. It might be difficult for some, it was very difficult for me. Unfortunately, I get very good at it. I can sell myself now, but it's intimidating to do that actually. You need to show the reviewer why you are perfect to do this research, why not somebody else. For multi-PI collaborations, you need to make sure that you highlight the collaboration. What is each of these PIs, what are they going to be contributing with? And I'll have a slide on that as well. And I'll read that question shortly. You want to add any intangible information about yourself and your strengths. Make sure that this is well put together. Maybe sound like boasting, but we have to do that. And it is a great place to indicate your strengths in a new area where you may have few publications, but you have to make sure that the space is provided, and it should be somewhere in the CV section or when you describe yourself. Okay, there's a question. What happened to someone who has not previously contributed in his areas of studies but has a good proposal? Can that kind of proposal gain funding? How can such person present the proposal in order to get funded? A very good question. And I would say there's a number of strategies really. And I would say the best idea from my perspective would be to partner with somebody who has done work in that area, is willing to work with you, and you can talk to them about your idea, what you have, and tell them that I would like to apply for funding. Would you apply with me? So in such a way, the proposal will be a little more trustworthy, and you will be able to get funding as a result. So I think that's one strategy. The other one is sort of to hold on the idea, get some papers out. One might be sufficient, two is probably a little better, or at least second submitted. And then you will have some track record in this area. And if your idea is good, hopefully you will get some papers out of that. And then you should be able to get funding as a result. So two different strategies. There might be more, but these are two that sort of come to my mind. Hopefully it was sufficient, but let me know if you have more questions. All right, so how about your research team? You need to describe what is everybody bringing to the table. You don't want to be putting people on because they won the Nobel Prize. I kind of have tried that, it didn't work. So you want to make sure that you describe what everybody will be doing, what their role will be in the project. Have you collaborated before? If you have, it's good. Nobody will question the potential collaboration. Is it something that you're just putting on your proposal to get the funding? And if you haven't, describe why not. How can you convince the reviewer that this collaboration will be successful? So something to think about as well. Might be in geographical proximity. You could have collaborated, but they were busy and you were busy. So there's reasons why why you would have not collaborated, and you have to convince the reviewer that this collaboration will succeed. If CV of the collaborators is not part of the application, you need to submit letters of recommendation, for example, to make sure that the reviewers understand that these people will be happy to collaborate with you. And in Canada, we actually have to say how often and how we will meet with our collaborators. So that's also important. And how will be the budget split? You need to describe that as well. So I'll just conclude with this with some random thoughts. I'll go into how to review, but I only have a couple of slides. If you should be getting letters of recommendations, make sure that you get some good ones. Unfortunately, sometimes you have to provide some drafts. So if you have to, please do that. Spend time looking through requests for applications or funding opportunity announcements because they come up. Talk to people who served on the review panels to find the right fit, but you cannot talk to the current members. Won't go into detail with that, but there's also a very clear difference between Canada and the US in this regard. Take advantage of grant review services at your institution and professional societies. There's always help, VR help right now, but if your institution offers some services, take advantage of them. And if you're putting together a big team for a large grant application, make sure that you give the entire process a lot of time. You want to meet with everybody at the same time, which by itself could be 1 month lost there because nobody's available for a long time. So about timeline. So I think, depends sort of what grant you're working on, but I think you should have your project idea in your head for about 1 year or even longer if you need to create preliminary data. You give 1 month to write your goals, your aims page, then you write the proposal itself for 2 months or so, you get feedback for 1 month, and then final read for 1 week. So if you just look at this, I'm just talking about, maybe a $200,000 proposal, this is already 1.5 years, which might be the same for bigger proposals as well, but make sure that you give yourself enough time to put together a really well put together proposal. And I would say it's also very important to step away from writing for some time. Finish it up, send it for feedback, and don't look at it for a week or even 2 weeks or 3. And then when you come back to it, you'll basically have a completely fresh mind and you'll catch typos, you catch inconsistencies as well. So I think that's something important as well. I'm just going to present here my ALARA principle for grant writing. And probably all know what ALARA means in radiation protection. But for me, you should be working on your application for as long as reasonably achievable. And in that way, we're going to follow these 3 principles as well, which is time. You need to give yourself a lot of time. And I hope I was pretty clear about that. You should step away from it, give some distance to it. And in the meantime, you can get some peer feedback. And the last one is not shielding, it's revise. Revise and revise. And what I like to call it, cuddle with words. It has to be a well-sounding, well-readable proposal. There's some final tips and tricks. Attend workshop and tutorials, read the evaluation criteria. Think about your research when you're not at work. It's very important as well. You get some great ideas when you're not at work. Prepare nice figures. Pay attention to project title. My biggest project to now has a typo in its title. Set aside 1 week of uninterrupted writing if you can. Get feedback from peers who are familiar with the granting agency, also very important. And be consistent across all documents. Don't say one thing in one document, another thing in another document. And again, give writing a lot of time. So I do have Arun, I have maybe 3 or 4 slides on how to review a grant proposal. Would you like me to go through that, or did we run out of time?
So quickly you can read now.
Second?
Quickly. Yeah, quickly yeah, you can do it. Yeah, wait.
All right, very good. And so now you're asked to review a grant proposal. What do? It's scary. Sometimes it can be actually very scary. So some questions that you should ask, very similar to reviewing papers, but the time commitment is much, much larger. So you need to ask about the review timeline. Make sure that you understand when the reviews should be submitted. It's not going to be in 2 weeks. It's going to be probably a couple of months, but you need to make sure that you actually are available. You need to assess whether or not you have enough time to work on this, to review the proposals. Are these proposals of interest to you? Is this your research area? And how many proposals do you have to review? It can be 1, it can be 10, and it makes a big difference. Are you familiar with the granting agency? Do they offer tutorials or help on how to review? So those are questions to ask them back. Have you submitted to the granting agency? If you have, similarly to what Robert was saying, if you have, it's pretty given that you should be reviewing for them as well. It's basically service back. Somebody reviewed for you, you should be reviewing for others. Is this valuable for your career? Most likely yes, but there might be instances in which it's not. So evaluate that. And sometimes granting agencies offer compensations. Unfortunately, most likely they don't offer compensation. So how to review grants? Similar to writing, you want to set aside a lot of time and ideally uninterrupted. One of my first horror stories is my first big grant or first review panel that I sat on. The grant actually had 300 pages, one grant, and I had multiple to review. So depending on the grant length, topic overlap with your research area, you might have to spend days on a single proposal. So as I said, my first one, one of the first ones had 300 pages. Do expect to be looking up a lot of information. Projects will be unlikely completely matched to your expertise. So make sure that you have enough time and that you give the proposal justice. You will learn a lot, which is great. Sometimes you might not be interested or not have knowledge in a certain area of research, but you will learn a lot. Try to look past typos. Sometimes it might be difficult, and grammar, and focus on science. So what do you do actually when you review a grant? You typically summarize the project and its goals. And often you can do this copy paste from the grant proposal itself, but it's good for you also to rephrase to make sure that you understand what exactly they're doing. You should highlight the strengths and weaknesses, and that's very common for all applications. Similar with papers, you should be fair and provide helpful feedback. It's possible that this grant will not get funded. The authors or the applicants will get the feedback back. They want to be able to improve the application based on your feedback and resubmit. Write in such a way that you could defend your feedback in a face-to-face encounter with the applicant. And I think the same for papers, not that this is ever going to happen, but write it in such a way that you could defend it. Make sure that your scores are supported by your written feedback, again, very similarly to papers. And if you're presenting a grant in a meeting, so somebody has to present it sometimes, do the work justice. And sometimes you might actually have to fight for your proposal. Other people might not have been fond of it, but you do think this is a really good proposal. You might have to fund it and defend it. So I think this is my last slide. So some final words of wisdom. Be persistent in grant writing. It's very important. Remember that similar with papers, most grants actually do not get funded. So don't give up when your proposal gets rejected in the first submission. It's very common that that happens. Address the reviewer's feedback to the best of your ability and be polite in your responses. Again, similar to papers, revise and make sure that the second submission is the best submission that you can put together. Also review grants if you can. It's a great learning opportunity. But even with all this, do know that luck is unfortunately important in grant review, perhaps even more so than it is with paper review. This is just a tweet from Andreas de Block, who was looking up, what happens with the review process, if we should even have grant review process, if we should even be applying for grants, because we spend a lot of time and a lot of money applying and reviewing grants. And one of the conclusions from the Australian Medical Research Funding Agency, NHMRC, was that 59% of the awarded projects would not have been awarded if they had been evaluated by other available reviewers. So this is a pretty startling conclusion here. So you might have to get lucky with reviewers as well. And with that, I would like to wish you good luck with writing grant applications and receiving grants as well. I'd like to acknowledge some people that have helped me with my last big grant, and that would be people from outside of my institution. So make sure that you reach to outside of your institution, people at my university, which were researchers as well as grants officers, and as well as my husband, whom I asked to review my paper just to make sure that it's understandable, or my proposal, so that he understands it as well. And I felt better about when he said he did, and look for typos, of course. And with this, I would like to thank you for your attention, and I will be happy to take any questions you might have.
Thank you, Magdalena, for the excellent talk on how to write a project and what are the points you have to look into before submission. Revise. The ALARA principle you have brought into the writings. Thanks for it. The questions you went on seeing into the chat box, and immediately you have tried to answer them. But some points or some opinion I would like to get from you is that many a times that funding agencies, they find that they have available funds to be dispersed at the last moment or at the fag end of the financial year. And this happens mostly into third world countries. And
no, it happens in Canada very often.
Okay, I have experienced this thing, and they disperse, and the deadline is that within 3 months or 4 months or 5 months, most of the grants, equipment establishment you have to do, and there is a huge bureaucracy of purchase of equipment, because you can put the request to the purchase department, they have set procedures, and the equipment has to come, it has to get installed, the training, appointment of the research staff, their
Yep.
training, and establishing, and the timeline, meeting the timeline of submitting the report, and the auditing of the things is a very, very difficult. So in those cases, what are your messages or your thought process?
Yeah, I'm not sure, this is a very difficult situation, and I'm up against it, sometimes as well. And I'm not sure if there's any solutions, if governments were better organized, it would be a little easier. There's issues with, if you're trying to hire somebody from abroad, issues with visas, with COVID, embassies are being closed. So that's definitely a thing here. Now, for us, I just told today I'm renovating a new space to get a new lab. I was told that now it takes 6 months to get a door, not shielded door, any door. It takes 6 months for a door to arrive. I think we just have to, deal with what we have, and basically ask for forgiveness later on when we are not delivering the projects on time. I think everybody should understand, because there's so many constraints at so many levels at this point, that people just have to accept what we can do with what we have available at this point.
And more so in multidisciplinary or multi-departmental projects. Yep. Or multiple institutions where they are involved, to have a coordination and things, and getting to the timeline and submitting results becomes quite difficult.
Yep, it is difficult.
Regarding review,
can I just make a brief comment to this?
Yeah.
I think something that I learned through the years is that essentially a grant, and maybe it's different in different parts of the world, but a grant essentially means that somebody trusts you with the money to do the most what you can do with that money. So it's not really literally to do what you promised in a grant. It has to be in a broad sense, but it's very different from a contract. There are funding agencies where they do the contract when they say, this is what you have to do, but that's the agreement that you have to, like just any contract. But grant in general means much broader. So, obviously you think what you're going to do, you promise, but it has to be, how to say, not necessarily down to the ladder. However, on the other hand, a big mistake that's often done, that people promise way too much to do with way too little money. Yep. In way too short time. And, of course, that's always something you want to play, but the reviewers will know that it's impossible to do something with too little money in too little time. So I think that realism that you write in a grant is very important as well. So
yeah, you don't want to overpromise with the time and funding, for sure. But this is a different situation, right, that Aaron was talking about. It's just the bureaucracy, really, very often.
No, it is bureaucracy, but that's, again, it's bureaucracy. But I think the main distinction is that there are grants and there are contracts. And the contracts means that you agree to something to be done. In a grant, you're granted money to do something that you can promised. It's a little bit different, at least the concept that I've seen.
Yeah. And you talked about the review process and reviewing, and the reviewer is a voluntary process as far as the projects are concerned, or it is also can be honorarium, can be received, or some funding agencies do give honorarium, right?
Right. So it depends. And it's an interesting question. So I think often there, at least in Canada, probably the US, I'm actually not sure about the NIH, what they do. But in Canada, basically what you get as a reviewer out of this is a trip to Ottawa, to the capital city, and you get to meet new people, and you get to spend 3-4 days reviewing grants, but also mingling and networking and making connections, right? So, but you don't get paid. Now with everything moving online, we actually get $50 per day for reviewing. It's not an honor, I forget how they call it. It's not quite an honorarium. However, some of my friends, they're in astronomy, so different field of physics, but I think it was a Russian agency that one of my colleagues got contacted by, and they paid him like $3,000 per like a 2-page grant. So, and he got like multiple grants, so he made a lot of money. But it was in first year. Second year, they gave him maybe $1,000 per grant. In the third year, they sent him more grants and said they were not going to pay him at all, and he declined to review at that point. So it's kind of interesting. So people can offer honoraria, but that might be just temporary. It might not last forever. But none of the granting agencies that I reviewed for, apart from CIHR now giving $50 a day, gave me any money. How is it with the NIH, Robert? You don't get paid either, do you?
No, you get paid per diem and reimbursed expenses. But I've got how to say, you get paid. I got paid or offered to be paid from multiple agencies, but often the payment also triggers the tax implications, and so often it's not even worth to go
through the taxes,
because it's not enough to get it. So and most of the I would say most of the agencies around the world are actually doing some kind of reimbursement and honorarium, because otherwise they have a hard time getting, and they just budget that. I don't know how it's like your experience, Arun, but yeah.
And regarding the journal papers or articles reviewing, it is for the reviewer, it's entirely a voluntary. I presume it's a voluntary, because sometimes rarely I get requests from the reviewer that will I get some the remuneration or honorarium for reviewing this thing. Is there any such kind of practice? No.
I don't know if any. I've never heard of any journal. But the funding agencies are different, because they do have funding. So some of the money they just allocate for the reviewers, and especially, I should say, and I don't know how it's in different parts of the world really, but like for very large, like standard grants, the review process is multi-stage process, or something Magdalena didn't talk, but that some grants have multiple steps. So they might have a screening phase where they just like let you write a letter of intent and briefly describe the idea. So it's very important that first page that Magdalena was saying, that you write very carefully, because that would get you into the next phase of the grant writing. But then you have like these big grants where they would often you would need to have advisory committees. You would need to get a site visit. So you would have like the committee that would actually come and review the grant. So, but I think this is beyond the scope of today's presentation. So, but if anyone is interested, happy to share those experiences as well.
So we have no more questions in the chat box, and we have discussed every aspect of the paper writing, reviewing, and everything. Also for the project writing and reviewing. So if nothing more is left, let me thank Robert Gerard and Magdalena for sparing the time and in the midnight. Thanks to AAPM and the group which you initiated. And I hope that the further collaboration and a lot of queries you will get, because you have shared your email, and email is people know about you, and we will be in contact, and maybe a follow-up of this kind of webinar we may have after a few months, if there is a interest is shown from the participant or somebody else.
So I'll just maybe add to this. So yeah, thanks again for giving us an opportunity to be able to share this. This is really the first time that we are doing it. It's not the first time we are doing it in this way. We did it last year in a similar way for the Worldwide Innovation in Medical Physics initiative that we did another meeting. But we would really love to hear back. So what do you think about this? Is there something you would change? Is there other topics you would like to hear? Are there other interesting, how to say, research and innovation related? Because as I said, like there are other committees within APM that are more focused on graduate education or professional education. So, but really specifically for the research education, for example, partnership with industries, etc. How you start up a company or things like that. Now, obviously, that's different parts of the world, but rules are, some basic fundamentals are very similar. So if there is interest, either in, things that you would like to hear, like any feedback, and, that's like reviewers, every feedback will be well taken. So good, bad, we would like to hear it. If you'd like to have other things, let us know as well, and then we can try to organize, follow up with this. But if you have any individual questions, Magdalena's or my email is always open 24 hours a day. Even like now it's like 4 a.m. Here. So if you have any emails, you'll get and 2 a.m. for Magdalena. So you see, we are up all the time. So thanks again for the opportunity, and really looking forward to many more interactions.
The continuous process of the AFOMP and also IOMP to disseminate the knowledge. And definitely I will come forward with some plan after discussions with my colleagues also and with you also, because a lot of aspects are there. The patenting is there, the property rights are there, so many things about the publication research thing. So we can have the webinar, this kind of things in time to come, because it's a continuous process. So once again, I thank you. And just as you can see that all the delegates also, you can see that routine monthly AFOMP school webinar, the 5th in this year, is going to be on 20th May. And already the information is on the AFOMP website. It's all for free. It's a CPD accredited, and this webinar is also CPD accredited. 2 points CME points, CPD points for 1 hour. That means at least 4 points they will get. Also, the routine monthly webinar will be on 3rd June, and this is on the nuclear and radiological emergencies, role of medical services. This is from Dr. moderated by Dr. Mary Joan. And AFOMP has every year the AOCMP. The next AOCMP annual meeting will be in Taipei, Taiwan during December 10 to 12. The website and the abstract invitation is on. They can visit, everyone can visit the site and submit their paper. Next month, we have the World Congress, which is in the hybrid mode. If you can attend in person, fine. If you cannot, you can join virtually. With this thing, thanking once again to Dr. Robert Deraj, Dr. Magdalena, Dr. Rajni Verma, Jin Chians, the Chai Hong from the AFOMP, and all the delegates. I close this special AFOMP school, and we meet again on 21st May for the AFOMP regular school. And I look forward to having some kind of lectures or webinars from Robert and Magdalena. Thank you very much for sparing your time.
Thank you.
Bye.